The future of clean energy, it needs minerals. Our defense systems, they absolutely need minerals. And right now, the global supply of those materials is, well, it's ground zero for a high-stakes geopolitical war.
It really is. We're looking at a stack of intelligence reports today from the International Energy Agency, U.S. Defense Reviews, and they all paint a very similar picture.
Which
This
is,
is China's near total dominance over the processing of these critical minerals, and on the other side, the frantic, almost surgical response from the
yeah.
West.
So our mission today is to unpack this high-stakes competition. We're going to focus on how China's dominance accelerated and, maybe the most surprising part, this unique containerized counter-strategy the U.S. military has launched.
Right.
And to really set the stage for how urgent this is, let's start with a quote from one of the sources. It's from a munitions advisor for the U.S. Army, and it's a stark one. An army without bullets is just a parade.
Wow. Yeah, that quote, it just immediately grounds the whole conversation, doesn't it?
It does.
I mean, this isn't some abstract crisis about gigawatts. It connects this huge energy transition to the gritty reality of national defense. We're not just talking about massive lithium mines for Tesla.
No. We're talking about things you can barely see.
Exactly. Microscopic materials like antimony trisulfide. That's the explosive cap that makes every single bullet function.
So today we're deep diving into the geopolitical control points, the specific military uses for these minerals, and this bespoke American response using these high-tech modular refineries.
Let's do it.
Okay, so let's unpack this, starting with Section 1. China's widening choke point on the global stage. When you look at the data from the IEA, the scale of China's lead, frankly, it's breathtaking.
It is. And what's fascinating here is understanding the real geopolitical so what of it all. The IEA report basically says for the foreseeable future, if the world is transitioning to clean energy, it is doing so through supply chains that Beijing commands.
And the key is that it's not about who has the minerals in the ground.
No, not at all. It's about who controls the processing, the complex industrial conversion process. That's the real choke point.
Right.
I mean, the stats are they're hard to ignore. China and its ally Indonesia account for 90% of new nickel refining capacity since 2020. 90%.
And it's even more extreme for others.
It is. China controls over 90% of refining for graphite and rare earth elements. They process 60% of the world's lithium and cobalt. It's this control over turning, raw dirt into a usable battery cathode or a high-tech magnet that's the real geopolitical weapon.
So that processing power lets them directly manipulate the market. How does that affect anyone trying to compete, say, a Western company?
It creates a huge deterrent. The biggest one is price volatility.
Okay.
China's state-backed companies have flooded the market. They've intentionally suppressed prices. I mean, look at lithium. It fell over 80% from its peak in 2022.
80%.
When prices collapse like that, it just completely destroys the economics for any new non-Chinese project.
So if a Western government or a company wants to build their own supply chain, they're starting at a huge disadvantage.
A massive one. These new projects are about 50% more expensive to build. Chinese subsidies keep their costs artificially low, and then you add in the slower permitting outside of Asia, the lack of long-term contracts. It just scares investors away.
It makes diversification sound less like a goal and more like an illusion.
Right now, it's a long-term illusion, and the dependency isn't just on the current tech. Even with new battery chemistries, the problem just shifts.
How so?
Well, take LFP batteries, lithium iron phosphate. They use less nickel and cobalt, which is great. But China controls 75% of the market for purified phosphoric acid, which you need to make LFP batteries.
So you're still dependent.
You're still dependent. It's an entire ecosystem of leverage, and it lets them weaponize their position like we've seen with export controls on gallium and rare earths. It forces every other country to stop and reassess their entire defense strategy.
Which brings us perfectly to our next section. We've talked about the gigawatt energy scale. Now we need to pivot from those huge supply chains to the second, and you could argue more urgent, front in this battle.
From gigawatts to grams.
Exactly. Securing the tiny, specialized components for modern warfare. This is where a supply chain problem becomes an existential threat.
100%. Every single advanced weapon system, every jet, every missile, every satellite, it relies on this complex cocktail of niche minerals. You lose one ingredient, you could ground a fighter jet.
So let's break down this ingredient list. Let's start with, say, the things needed for high-speed flight, things that have to survive incredible stress.
Okay, the high-heat heroes, you could call them. You've got niobium. It's essential for alloys and hypersonic systems, things flying faster than Mach 5. These alloys have to maintain their structure at over 1700 degrees Celsius.
Just incredible temperatures.
Right. And then there's cobalt. People think batteries, and it's in drone batteries, sure, but it's also critical for the superalloys in a jet engine, like the one in the F-35 fighter. The performance of that engine is completely dependent on cobalt.
Okay, so that's structural integrity. What about seeing, communicating, and hitting a target with precision?
The guidance trio. For pure guidance, you need neodymium magnets. They power the tiny control systems in a cruise missile, like a Tomahawk, letting it make split-second adjustments.
And for seeing the target?
That's germanium. It's vital for thermal imaging. The optics in a Javelin missile that let a soldier see a heat signature in the dead of night, that's germanium.
What about communications? The silent linchpin.
That's erbium. It's used in secure, long-distance military fiber optics to boost signals. And for radar, you need gallium. It's essential for the AESA radar systems that give modern jets their incredible targeting accuracy.
And this all points back to the same core geopolitical problem.
It does. China controls over 85% of the world's rare earth processing. So this dependency isn't on one or two weapons. It's across every major Western military platform.
Which means supply chain manipulation is a constant worry for defense planners.
A critical concern. And it forces the U.S. and its allies to look for these very tailored domestic solutions instead of trying to compete on the global market.
That sets up the problem perfectly, which brings us to Section 3, the specific domestic countermove. How do you solve a national security shortage when big industry is too slow or, just doesn't exist at home?
Well, the catalyst for this really unique solution was a very specific crisis, the antimony shortage.
Tell us about that. What happened in 2021?
In 2021, China just stopped shipping antimony trisulfide. That's the explosive cap for bullets we mentioned.
So no more primer for ammunition.
Yep. Exactly. It immediately forced the U.S. Army to start digging into its one-year strategic stockpile. It set off this desperate dash to find other suppliers in India, anywhere. They realized they had zero domestic capability for material you need for basic infantry.
And the solution they came up with is it's genuinely stunning. It's this mix of high-tech and industrial stealth. The containerized refinery.
It is. The Army spent $30 million to develop these small-scale modular refineries. The key feature is that the entire thing, the whole operation, can be transported in just 4 standard shipping containers.
A bullet factory you can move on a truck. The image of that it's just incredible.
Yeah.
Who are the partners making this happen?
The main industrial partner is a company called Perpetua Resources. They operate a project in Idaho that has the only identified antimony reserve in the country.
And the tech side.
The refinery itself is being tested at the Idaho National Laboratory, INL, and this has high-level backing. Perpetua has gotten up to $22 million in funding from the Department of Defense.
Let's talk about the strategy here, because the scale is small. 7 to 10 metric tons a year. Why spend $30 million for such a tiny output?
That small scale is completely intentional. It's resilience over scale.
Okay.
7 to 10 tons is enough for the Army's peacetime needs. But the strategic genius is the modularity. If there's a conflict, you don't build one giant factory. You just build more of these containerized units. You can scale up fast and you can spread them out.
So it's about having an assured domestic supply, not about competing with China on price.
Precisely. The goal is a fully domestic, ground-to-round supply chain for a material the U.S. hasn't made since the 1960s. It's all about control. As that Army advisor said, we need to come up with a way to make our own critical minerals domestically that we can actually control within our borders.
This kind of targeted spending on something that isn't commercially viable requires some serious legal firepower. So where does $30 million for a container factory actually come from? This brings us to the legal toolkit.
That money flows through one of the most powerful legal tools the government has. The Defense Production Act, or DPA, specifically Title III of the Act.
The DPA. People hear that and think of emergencies, like seizing masks during a pandemic.
Right. And it can be that. But Title III is different. It's not about seizing things. It's about industrial expansion. It gives the president the authority to ensure U.S. industry can meet national defense needs.
So it's a tool for building capability where the free market has failed to.
That's it, exactly. Title III provides the financial tools, loans, grants, purchase guarantees to help a company like Perpetua establish a production line. It helps them buy the specialized equipment for those modular refineries.
But the president can't just throw money at any project. There has to be a pretty high bar to use this power, right?
A very high bar.
Yep.
They have to pass a kind of three-part test, which is formalized in a presidential determination.
What's the test?
First, the resource has to be essential to national defense. Bullets, check. Second, U.S. industry can't be expected to provide it in time without government help, check. And third, using the DPA has to be the most cost-effective and practical way to solve the problem.
Yeah, and we've seen a huge increase in the use of the DPA recently.
A massive acceleration. It shows how urgent these bottlenecks are. Since 2020, Congress has funneled billions through the DPA framework. $1 billion from the CARES Act, $600 million for Ukraine to boost missile production, $250 million from the Inflation Reduction Act for batteries.
So it's become the go-to legal tool for fighting this supply chain war.
It is. The goal of Title III is, and I'm quoting here, to create, maintain, protect, expand, or restore domestic industrial capabilities. It's a clear admission that the free market alone can't guarantee national security.
This has been a fascinating deep dive. Let's try to summarize the core conflict we've uncovered here for everyone listening.
Sure. I mean, what we've really established is that the global shift to clean energy is, for now, built on supply chains that China completely dominates.
Right. And the West isn't trying to beat them at that game, at that massive commercial scale.
No. Instead, the U.S. is launching these highly specialized, almost secret domestic solutions, like the bullet factory in a box to secure its own military materials. It's a competition between massive commercial scale and hyper-focused national security.
Scale versus security. So what does this all mean for the future? We've used the Defense Production Act to solve the antimony crisis for bullets, but what's the next, maybe even bigger threat?
Well, we've applied a defense tool to a defense problem, but the commercial energy crisis is, I think, much bigger. We're securing these niche minerals, but the foundational materials are heading toward real scarcity. The IEA is forecasting a 30% supply gap for copper by 2035.
30% for copper. That's the wiring for everything: electric grids, EVs, all of it.
It's the backbone. So here's the final provocative thought for you to take away. We're watching the U.S. use the DPA today to secure materials for missiles and bullets. Given this massive forecasted deficit in copper, which is essential for the entire clean energy transition, will governments eventually have to apply this same national security playbook to the fundamental building blocks of our commercial economy?
What would it look like if they declared a national security emergency over copper?
Exactly.
That definitely puts the challenge into perspective. From bullets to the entire electric grid. Thank you for guiding us through this.
My pleasure.
That's it for this deep dive. We'll see you next time.